All right, so good afternoon, ladies and gentlemen. Our objective for today is that students will be able to create a table and an equation to represent an example of exponential decay. All right, so today we're talking about exponential decay instead of exponential growth. Now, the two are similar, they're both exponential, but when we're talking about things that are decaying, that's an example of things that are decreasing, right? So it's an exponential relationship where you're multiplying, but instead of things getting bigger, they're actually getting smaller, right? And the example that we saw yesterday was actually an example of that, right? When we talked about the area of the pieces of paper, the area got smaller and smaller, and you saw that you were multiplying by 1/2 or 0.5. So an example like that, we don't call exponential growth, we call exponential decay, right? And instead of talking about growth factors, we talk about decay factors. So a decay factor is always greater than 0 and less than 1. So here's a quick line graph just to kind of give you an example, right? If we think about numbers between 0 and 1, numbers like say 0.05, 1/2, 0.7, those are decay factors because multiplying by something that's smaller than 1 causes your result to get smaller, right? If I take the number 10 and I multiply by 1/2, I'm going to get 5, so it'll get smaller. Growth factors are when you multiply by something that is larger than 1, that causes it to get bigger, right? Even if it's something that's barely larger than 1, like 1.05, that's still going to make it get bigger, right? I could also have growth factors of like 2, 5, 10, any number that's larger than 1. So that's how you tell the two apart. If it's less than 1, it's a decay factor. If it's bigger than 1, it's a growth factor. You're also going to notice that it stops at 0 because you never have negative decay factors or growth factors, all right? So example for today, we're going to look at an example of exponential decay. I'm going to walk you through the first part, and then you're going to try another one on your own that's very simple. So it says, after an animal receives flea medicine, the medicine breaks down in the animal's bloodstream. With each hour, there is less medicine in the blood. A dog receives a 400 milligram dose of flea medicine. The table and graph below show the amount of medicine in the dog's bloodstream each hour for 6 hours after the dose, right? So over here, I have a graph, I have a table. When you're talking about exponential relationships, they tend to have a curve, right? Exponential growth has a curve in the opposite direction where it's increasing. Exponential decay starts at the top and starts decreasing because the values get smaller. So the table on the right is where we want to focus. That's showing us what's happening. So it told us that we started off with a dose of 400 milligrams, and we want to figure out how this is decreasing. Just by looking at the curve, I can tell it's exponential, but I want to try to analyze this to figure out what's going on exactly. So initial value is always the same. I'm looking for time 0. 400 milligrams is how much we started with in the dog's blood. Now, the decay factor over here is the same way we find the growth factor. I want to figure out what am I multiplying 400 by to get to 100. And the way that I do that is by dividing. So in a calculator, all I need to do is 100 divided by 400. I see, 0.25. So in this case here, my decay factor is 0.25. And I could check that out, right? If I, again, take 100 times 0.25 to see what would happen next, I see 25. Does that match the table? Yes. And then I say, all I have to do again is actually multiply again by 0.25. And I see I got 6.25. Yep. I multiply again by 0.25, 1.5625, right? So that looks like it works as my decay factor. Now, this is where it gets tricky. We're going to practice this a little bit more tomorrow. So if this part confuses you, don't worry. What is the rate of decay here? So similar to a growth rate, it's saying what percentage is the medicine decreased by each hour? So what am I decreasing by? Now, when we talk about growth factors, I said, okay, so I'm going to just get rid of so I'm actually just going to convert this part into a decimal, and it will be 25%. But going from 400 to 100 is not a 25% decrease. That's actually a 75% decrease. And again, we're going to practice this particular skill a little bit more tomorrow. So the rate of decay here tells me that going from 400 milligrams to 100 milligrams, it decreased by 75%, right? It decreased by more than half. Half of this would be 200 and went to less than half, okay? So again, don't worry too much about that part. Focus on the decay factor and the equations today. Now, if I want to turn this part into an equation, I have the two variables here. It says the number of milligrams is given by M, the number of hours is given by H. So dependent, independent. Dependent, the number of milligrams, right? That's what's on the left side of my table. So the dosage I'm gonna find by taking my initial value, which was 400, multiplying it by my decay factor now, not my growth factor, 0.25, and raise that to the H power, because that's how many hours I have. And again, this is something that I can check to see if it works, right? Let's say I wanted to check to see, does this work for 6 years? So I could say 400, and let's go to my calculator. 400 multiplied by 0.25 raised to the 6th power is what I would get for 6 years, 0.097, 0.097. So that equation looks like it works, okay? Now, we're gonna do the same exact thing for the next table on page 3. Look at this table. I started it out for you. I have the initial value, year 1. First, identify the initial value, use these 2 years to identify the decay factor, finish filling out the table, and then rate of decay, just give a shot at that. Again, we're gonna practice that more later. Come up with your equation, all right? That's it for today. If you finish early, you can go to the push yourself section on the next page, right? If you have any questions, the Zoom session will be open at the regularly scheduled time, right? Thanks everybody, good luck.